So, well, the plan for today's the review day. It's been on the calendar. That's fair. So to the goal for today, we'll talk about the test format, take any kind of last minute questions, give you time to work on your half sheets. Ideally, you hand me that before you leave today. And once you finish with that, you'd start on your review, right? All right, so the test format, you have 2 questions where I ask you to solve a system of 2 equations by graphing. I'd ask that you include your graph and a table of points that you use to graph the 2 equations, as well as the solution. Yes, Reese?
Would that be like the one that you did on the homework quiz?
Yep, except I'd ask for points for the table, like a table of points in addition to just the sketch from your calculator. One question I ask you to solve the system of inequalities. Again, just like you did on the homework quiz. You have 2 questions where we want you to solve the system of 2 equations by substitution or elimination. So those will be 2 variable systems. And then 2 questions where I give you a story problem. From that story problem, you'll write a system of 2 equations and then solve that. Give you one question when we solve the system of 3 equations using substitution or elimination. And 1 question where I ask you to write the general solution for a system of 3 equations that has infinitely many solutions. Questions? Reese?
An example of like a story problem.
Yeah. Let me find one here.
Yeah.
Okay. So let's say we have, let me just do that. That way that'll be easier. All right, Reese, here we go. So this is from the review. It says, at a bake sale, cookies are sold for $2 each, brownies are sold for $3 each, and a total of 25 items are sold altogether. If the money made from the cookies and brownies is $65, how many cookies and how many brownies are sold? So the way I would start any kind of problem like this is by beginning by picking a variable and deciding what that variable is representing. So what are we being asked to find here? Okay, so how many variables will we need? 2. Okay, let's pick the letters C and B. What is C going to represent? Let's try to be a little bit more specific. Number of cookies sold, yep. And B will be, great. So far, so good? Okay. Now, once I've decided what my variables are and what they're representing, I'm going to go through and look at the information that's given to me and try to kind of organize that and write down maybe what it is, right? So the first sentence says, cookies are sold for $2 each. So the cost per cookie equals $2. Everybody agree with that? Brownies for $3 each. So the cost per brownie equals $3. A total of 25 items are sold altogether. Well, that to me sounds like an equation right there. What equation could I write from that? What are the items? So it says 25 items are sold altogether. So to me, when I read that, it tells me that something plus something had to equal 25, right? What are the items that they would be saying if we say 25 items are sold? Cookies and brownies, right? I agree with that. Everybody's okay with that? It says, and the last sentence says, the money made from cookies and brownies is $65. So I would say that money from cookies plus money from brownies equals $65. Everybody agree with that? So that sounds like almost an equation, right? I just need to figure out a way to write the monies from cookies and the money from brownies symbolically. Billy.
2C plus 3.
Excellent. 2C plus 3B equals 65, because I know that the money from cookies must be the cost per cookie times the number of cookies. So 2 times C. And then the money from brownies must be the cost per brownie times the number of brownies, 3B. Once I have my system, now I'm just going to solve this. You can use substitution, you could use elimination, doesn't really matter. I'm hoping that at that point you feel pretty confident on that piece, but the setup. Should we do another? You think you're okay? Others, other people's. Should we do another like this?
Wait, so is that it?
Well, you have to solve the system,
Oh,
but like the equate, that's the hard part,
okay.
right? Like substitution, elimination. I'm hoping in two variables in particular, you guys feel reasonably confident in your ability to do this. Writing the equation from scratch, that can be a little trickier. But again, like write a lot of it in words, like we did here, before you go to symbols. If you go try going straight to symbols, some of us are really good at that. Some of us are, that's hard. But the more we write symbolically, usually the easier, or the more we write like in words, the easier it is to translate it to symbols. Should we do another story problem one? Let's do it. Right? Again, this is just coming from the review. It says, at a movie theater, 2 tubs of popcorn and 3 large drinks cost $24. At the same theater, 3 tubs of popcorn and 5 large drinks cost $38. How much does each item cost individually? So what are we looking to solve for? Alondra. Great. So let's say P is equal to the cost per popcorn, and D will be the cost per drink. Now let's go back and read the rest of this and try to figure out how to write some equations here. So the next sentence says 2 tubs of popcorn and 3 drinks cost $24 total. So I know that the cost per popcorn times the number of popcorn and then the cost per drink times the number of drinks should equal the money spent, right? But do you agree that that's just kind of how life works? And so if we do that, we can say 2P plus 3D equals 24, and then 3P plus 5D equals 38. And there's my system I just need to solve. Everybody feel okay with setting that up? They all kind of feel kind of a piece like this. They're usually not too bad. Any questions from homeworks or any other review-ish type questions? Yeah.
Can you do an inequality one?
Sure. Yeah, let me grab one of those. So I'm going to, this is just from the review. I'm going to color code each of these because I can right? All right, so Wade, the first thing I'm going to do is I'm going to rewrite the equation so it's in slope intercept or slope intercept form. So I'll subtract the x from both sides. Then I'll pretend it's an equation and come up with 2 points. So maybe I'll pick 0 for x. If I do that, I get 4 for y. Or if I pick 4 for x, I get 0 for y. I'll do the same thing over here. I'm going to add x to both sides this time. Now, what do I do if there's no place to plug an x in? It doesn't matter because whatever the y or whatever the x is, the y is still 3, right? And same thing over here. If there's no place for a y, well, then it doesn't matter what the x, or the x is always -2. It doesn't matter what the y is. So far, so good?
Yeah.
Okay. Go ahead and sketch myself a picture here. One, two, three, four. 1, 2, 3, 4. Now, because this is a strict less than inequality for the red, I know I'm going to have to use a dashed line.
And if it's greater than 4, it's
Correct.
Okay.
And we're going to be shading down because it's a less than, so I'll just draw like a little down arrow there to remind myself which way that's shading. Okay, my next one is 0, -4. 1, 2, 3, 4. And then 4, 0. Oops. This one also needs a dashed line because it's a greater than, or a strict greater than. And this one is shading above. So I'll just do one of these. So we're now like in between these two lines, right, somewhere. I will do the yellow there. So I have 0, -0, 3, and then 1, 3. Because these is a less than or equal to inequality. This one's going to be a solid line. And because it's a less than or equal to, we're shading below. And then my final one is the green. So we have -2, 0, and then -2, 1. Oops. Jeepers creepers. And again, because it's not an or equal to, this one needs a dashed line also. And because it's greater than, we're going to be shading to the right. So the region that we're interested in is going to be the stuff that's between the green, yellow, red, and blue. So it's like that region in here. That makes sense? But that's the gist of it, right? Not so bad. Have to remember when things are solid or dashed and which way to shade, but
What is it like? Which way to shade? Like it's less
mhm.
than.
Yes. And the only thing that's weird is if you have a vertical line, then greater is right and less is left. But that should make sense, right? If you think about like the number line, big stuff is to the right, the small stuff is to the left.
Yeah.
31 from the homework? Sure. Oops. Okay. What method did you use to do this one? Did you do substitution or elimination? Okay. And which variable did you choose to eliminate first?
X.
Great. So did you do equation 1 plus equation 2?
Yep.
And then did you do 2 times equation 1 plus equation 3? Okay. I just want to do it the same way you're doing it. So if you've made a mistake, it's easy for us to find it. So let's see. We have 3y minus z equals 5 for that one. Then 2x plus 10y minus 4z equals negative 2. Negative 2x minus 7y plus 3z equals 7. So that's going to be 3y minus z equals 5. I'd see that they are the same. So right away, what does that tell me?
That's for Y.
Well, that's for the whole thing. Now let's find the general solution, right? Because I'm going to ask you to do that. So we're going to take one of those 2 variable equations that we have. Do you think it'll be easier to solve for x or solve for y or solve for z? What do you think is going to make life simpler? Yeah, let's get z by itself because we don't have to worry about any fractions if we do that. And in general, that's my goal in these problems. Just like I'm going to make my decisions to avoid fractions. So I'll add z to both sides and then subtract 5 from both sides. Okay with that?
Yeah.
So I'll start writing out my general solution here. So in the z component, I'm going to write 3y minus 5. The y component is just going to be y because I've written z in terms of y. Now I just need to find the x component. To do that, I'm going to take this equation, and I'm going to substitute that 3y minus 5 in for z into any of the 3 original equations. It doesn't matter which one. I'm going to choose to put it into the first one. So I'm going to have x plus 5y minus 2 times 3y minus 5 equals negative 1. And then I see to get the x by itself, those guys just turn into a negative y. And I add that over to get 1y. And I'll subtract over the 10 to get negative 11. So my final component then is just going to be y minus 11 for x. Mm-hmm. So I did 2.
Well, did you add equation? Oh, you did equation 1. Oh, I did equation
Okay. You could do that. You'd have to do -2 times equation 2
Yeah.
plus equation 3.
Yeah.
That would be okay. Should come out still to work the same way.
Why is it like? How do you know that's?
Because they were the same exact equation.
Yeah, but where's the? I understand how you get that one, but how do you get the one to the left? How do you get the 3y?
I just added those two together.
Oh, those are right.
Yep.
Mr. Cool.
Yes, sir.
How do you like know what equations to start with?
So it doesn't really matter. The
Okay.
goal is I want to eliminate, I'm picking one variable to eliminate. So in this case, Joey chose x's. And I'm just going to pick two equations to eliminate x from, and then two different equations to eliminate x from.
Okay, and then like the EQ1 and EQ2, that's like equation.
That's equation 1 plus equation 2.
Okay.
So like when I add those directly, the x's are going to cancel out.
Yeah.
And then the other one I did 2 times equation 1 plus equation 3.
Okay.
And if I do that, I'm going to have 2x and -2x. Those will add to give me 0 x's. So it doesn't really matter what you start with. My goal is just to like try to make it as simple as possible.
Okay.
Does that feel okay?
Yeah.
All right. And Joey, you said you did -2 times equation 2 plus equation 3.
Yeah.
Okay. So that should be 2x plus 4y minus 2z equals -12. And then 2x minus 7y plus 3z equals 7. So I have 3y plus z equals -5. Oops, -3y. And if you notice, that's just the opposite of that one.
But they'll be the same things.
If you add them together with the first one, they just get all zeros, which is also infinitely many.
Okay.
You know what I'm saying?
So,
So like this one would be -3y plus z equals -5. And if I add those two together, which is infinitely many.
okay.
Does that feel okay?
Yeah.
You catch your mistake?
Yeah.
Drop a negative?
I
Oh, okay. Do you feel okay now though? Okay. So again, this process that we did here was probably the trickiest thing I asked you to do, is come up with that general solution. But like once you've done it, it's like, okay, this is like, it's not that big of a deal. Alondra. The system of inequalities. Okay. Are you stressing about the absolute value? I'll tell you, you want to see an absolute value on your test, if that makes a difference. All right. I'll do this. You would not. All right, so the first one, let's get this into slope-intercept form. So add the 4 over, or 4x over, excuse me, and then divide by the 2. Then we'll pick some values for x and y. Maybe I'll pick 0, -2, and I'll pick 1, 0. The next one is already in, or already has the y by itself. Right? But I remember to graph an absolute value function, I need 3 points, but the middle point needs to be the vertex. So for any absolute value function of the form a times absolute value of x minus h plus k, the vertex is just h comma k. So here my vertex should be -2, 4. So I'll just pick one value less than -2 and then one value bigger than -2. So -3 plus 2 is -1. The absolute value of that is +1. Times -3 is -3. And then plus 4 is 1. So now I got everything I need. So 0, -2, 1, 0. This should be dashed because it's a or equal to inequality. The other one I have -3, 1, -2, 4. And then -1, 1. Again, this is going to be dashy dashy. Okay. And we're going above the blue, and we're going below the red. So that means our region that we're going to have is going to be like this one over here. Well, I guess this is probably keeps going, right? And I guess like eventually these two might intersect again down here a million years away, but I'm not too worried about it. Hi, dude.
Hey.
What's wrong? Oh, okay. What's wrong with the gray one?
I don't know, actually, the red one's better. The red one's like good luck. They just like make me better.
Okay. Alondra, you feel okay though?